All right, we're going to do, I think, 10 of these at a time. So here are the first 10. That looks weird. Here are the first 10 identities on this optional worksheet. Remember, you can skip around. This way it'll be easier to find the problems you did do to check. These proofs start off pretty short. So we have tangent of theta equals, I'm just writing down the original, sine theta secant theta. Start on the more complicated side, which would be the right side. Use the reciprocal identity on secant, so 1 over cosine theta. And sine over cosine theta is tangent theta, so that first one is finished. Number 2. Some of these, by the way, full disclosure here, I used some of these on our first trig identities worksheet, so they'll look familiar. But I've been saying there are only so many unique proofs that we can really do, or combinations of this. So number 2 is kind of the same idea. That's how a lot of these work. The evens and odds are similar. So same thing on this one. Let's change cosecant to 1 over sine theta, and cosine over sine theta, that's your quotient identity. That is cotangent theta. All right. For the third one, we have tangent squared theta equals 1 minus cosine squared theta over cosine squared theta. For this one, 1 minus cosine squared theta is one of our rearranged Pythagorean identities. It's equal to sine squared theta. You're allowed to write those when you take your quiz Monday. When you write out your identities, you have space to write the rearranged. So they're there for you to recognize. So this is sine squared theta over cosine squared theta, and that's equal to tangent squared theta. For number 4, similar idea here. Now we have secant squared theta equals sine squared theta plus cosine squared theta all over cosine squared theta. So let's start on the right side. Sine squared plus cosine squared is a Pythagorean identity equal to 1. 1 over cosine squared theta is secant squared theta. You do need to write the angles. Our quiz, these will all be x's. You need to write the theta or the x or whatever the angle is to get full credit for these problems. All right, number 5 is tangent squared. Oh, okay, these next two are kind of weird because this is the rearranged Pythagorean identity. So like tangent squared is secant squared minus 1. It's kind of like done. But if I'm proving this, if I needed to prove why the rearranged forms are possible, I would use the original Pythagorean identity I know. So secant squared is equal to tangent squared theta plus 1. And then we have this minus 1. So that would simplify to tangent squared. So kind of a short little proof. To be honest, I wouldn't expect anything that short. I'm not going to have you prove any of the rearranged Pythagorean identities because I'm saying that you're allowed to use them in the first place. So, all right, here's number 6. Same idea. This is a rearranged Pythagorean, so if I want to prove it, the one that I have is cotangent squared theta plus 1 can replace cosecant squared, and then there's a minus 1, and that's equal to cotangent squared. For number 7, we have cosine squared theta over sine theta plus sine theta equals cosecant theta. All right, so no identities that I can see. I have a fraction plus something else. Everything's in terms of sine and cosine over here. So I have a fraction plus something else. So the first thing I should try is getting a common denominator. So the common denominator would be sine theta. The first fraction already has the denominator, so it's just going to be cosine squared. The sine over 1 would need to get multiplied by sine theta over sine theta. And you don't have to show me that in your proofs, but I'm just doing that for explanation. So that makes this sine squared theta over sine theta. And cosine squared plus sine squared is 1. And 1 over sine theta is cosecant theta. For number 8, we have tangent theta over 1 minus cosine squared theta is supposed to equal secant theta times cosecant theta. Oh. Okay, so I would start on the left side because I see a Pythagorean identity over here. So I could change this to tangent theta over sine squared theta. And then usually when tangents and other identities are involved, it's best to switch everything to sines and cosines. So tangent theta is sine theta over cosine theta. And right now that's being divided by sine squared. Might be a good idea to show that that's sine squared over 1 because I'm about to multiply by the reciprocal. So sine theta over cosine theta, instead of dividing by sine squared, we multiply by 1 over sine squared because that's the same thing. Instead of dividing by 2, I multiply by 1/2. I can cancel this sine theta with one of the sine thetas in the denominator. So I get 1 over cosine theta times 1 over sine theta, or 1 over cosine theta sine theta in the same fraction is fine. And we're trying to get secant cosecant, which is what these two things are. So secant theta times cosecant theta, that proof is finished. All right, last two for this video. So number 9, cosecant theta is supposed to equal cotangent theta over cosine theta. So I think the right side is more complicated than the left, so I'm going to rewrite cotangent theta using my quotient identity. It's cosine theta over sine theta over cosine theta over 1, if you want to show that. Same trick we did last problem. Change this to a multiplication problem. Instead of dividing by cosine, we're going to show that we can look at that as times cosine 1 over cosine theta, and then the cosines cancel. You're left with 1 over sine theta, which is cosecant theta. All right, last one for this video. So number 10 is 1 over secant squared theta plus 1 over cosecant squared theta equals 1. Right, so 1 over secant squared theta is cosine squared theta, and 1 over cosecant squared theta is sine squared theta. I'm using reciprocal identities there. This is our first Pythagorean identity, which is equal to 1. All right, so these first 10 are kind of a good intro. So if you're good on these, you're ready for sort of the next level, which are the next 10. So try the next 10.